All right, welcome back. We are continuing on this second module, talking about the components of solar PV system. And we have talked about so many of them, like from solar panel, we have talked about battery. Now, concerning battery, we are going to talk about what is known as depth of discharge. So, what is depth of discharge? Depth of discharge refers to how much energy has been used from a battery relative to its total capacity. It is usually expressed as a percentage. For example, if a battery is fully discharged, it has 100% depth of discharge. But if you have only used half of the battery's capacity, that is a 50% depth of discharge. What this simply means is this, like I've explained before, batteries, when fully charged, most of them cannot give you everything they have. Do you understand that? We explained that lead acid batteries, both the flooded lead acid battery, sealed lead acid battery, and then their variation, which is AGM and gel batteries. Some of them, they can only give you 50% of the charges they receive. That is, if they receive 100% charge, they can only give out 50% of it. It simply means that batteries, okay, let's say the ones that are common in Nigeria, they don't give you 100% of their charges, the energy they receive. Do you understand that? So, for example, let's say you have 100 amps battery. If you use 50 amp, the battery is at 50% depth of discharge. So for some battery that, like lithium battery, that can give up to 80%, if you use 80% of that battery's capacity, it is said that the battery has an 80% depth of discharge. So the question is, why is depth of discharge so important in solar PV design and configuration? Listen to this. Different battery types have different safe depth of discharge limits. Do you understand? So different battery types have their own depth of discharge limit. Like I've said earlier, lead acid batteries, their safe zone is within 50% of their capacity. Lithium ion batteries, they give up to 80% of their capacity. And then you know about all those big large scale batteries like nickel cadmium and flow batteries. They have 100% depth of discharge. What it simply means that if you charge them full to 100%, you can discharge them to 0%. And then when you recharge them, they will still maintain their original capacity. Unlike lead acid batteries, if you attempt to discharge them below their safe zone, which is 50%, you are going to put the battery into trouble. You are going to affect the lifespan of the battery and then their capacity to deliver along the line. If that continues for a long time, it's going to result into the battery being discharged quickly. What you will notice, especially in flooded lead acid battery and other form of lead acid battery, it will quickly charge to it will quickly indicate that it's fully charged, and then as soon as the sun goes down, it will quickly discharge. Do you understand? So these are the effect of exceeding the depth of discharge of a battery. So this is important so that when you are sizing your solar system, you factor these things. Do you understand? So you know when to tell your clients that, see, that anytime such a thing happen, please shut down, allow the system to charge again before you continue to use. Good enough. Most of the inverters, our batteries, they come with BMS. We have talked about that before. That is battery management systems that help to manage the battery's life. One of the things the BMS manage is this depth of discharge, to ensure that the battery doesn't exceed, that you don't exceed the battery's depth of discharge. Do you understand that? So it is very, very important. These are the battery types and their typical safe zone of depth of discharge. Lead acid battery is at 50% maximum. Lithium ion batteries, depending on the make and the type, depending on the make, some have 80%. So, but let's say that lithium ion batteries have a safe zone of depth of discharge within 80 to 95%. So flow batteries can give up to 100%. Do you understand that? So using more than the recommended depth of discharge shortens battery life. We have said that already. Also note that lead acid batteries, for example, should not be regularly discharged past 50%, because it will stress the battery and reduce how long it will last. So the bottom line here is this: the higher depth of discharge of any battery is equal to more usable energy per cycle. That is, more usable energy before you recharge it again. But you must stay within the safe limit for your battery type to avoid damage. Do you understand that? Tell your clients, once you begin to hear alert, all those beeping alerts from inverters, please tell them to shut down. Some lithium batteries have their own inbuilt BMS, that once the battery get to their depth of discharge limit, they will give a warning, and then some of them shut down automatically. Then if it is a very modern hybrid PV system that uses this thing, that uses monitoring devices, there are systems, if well designed, you can monitor the battery with your Android phone from afar. Do you understand? So anytime the battery gets to depth of discharge, you can from your phone disconnect the system. That is, you have the capacity to shut it down from a distance using your mobile phone. So, but that is in an advanced PV system. That is, if it is well designed. So that kind of capability function well with lithium batteries because of the BMS and some kind of inverters. There are inverters that have those facilities that you can monitor the entire system remotely with your phone. It's just a little connection here and there, then you'll be able to control the whole system with your phone. That way you'll be able to monitor the whole system. You just be monitoring it, because some clients, they are wonderful, they will just want to use life out of the whole system. Do you understand that? Even when they are hearing the beep sound, pim, pim, they will just sit down there. Some of them, out of laziness, will just sit down where they are instead of to go and off the system. Do you understand? Some of them is their children, children that doesn't know value of things. Do you understand? So they'll just want to suck life out of the system. The system will just be crying, pim, pim. They will still insist until they drain the whole battery. That way, they are putting your system at risk. And this is one of the reasons why you hear people complain about their solar installation. It now looks as if the solar installer doesn't know what he is doing. You understand? If they continue to exceed the depth of discharge over time, within 3 months, the system will begin to have problem. So that's why you see people, they say they install solar, within 6 months, the solar started misbehaving. Do you understand? So some of this problem is traceable to exceeding the depth of discharge of the battery. So I'm saying this so so that you know how to avoid that. Put some things in check. Although the challenge we have here too is that there are so many installers, so the market has now become competitive. Ordinarily, all those things are what you're supposed to factor in when you are, drafting your budget or proposal for it, because you will not use your money to put BMS for clients now. It is from their money that you will factor in BMS, remote control, and all of that. So, but in the case where they have limited budgets, you just have to cut off some things. Then if that be the case, you must have a rule that you give them. Once they hear PM from the system, they should off it until when the system is fully charged, or maybe they should off it and contact you so that you know the kind of the notification the system is giving. I hope this is well understood. Do you understand? So if you have any questions regarding this depth of discharge, because it's very important, please ask me on the comment section, ask me anywhere. Look around this video, you must see a way to ask me questions regarding this. Or better still, do your own research about depth of discharge of batteries. As a matter of fact, any battery that you want to use, one of the questions you will ask before buying it is, what is the depth of discharge? What is the safe zone? What is the limit? You can Google it. You can ask the dealers. So some of them come with manual. They will tell you this is the safe zone, and then how to navigate around all those things. So that is that about depth of discharge.